Good afternoon. I'm Laquita Brown, U0194061, discussing my uh, my video of Module 1. Um, and first, we're going to develop 4 questions and answer them to summarize this module. So, how is the scientific method used to test hypotheses? Hypotheses are tested in controlled experiments or in observational studios whose results can either support or rule out hypotheses. Hypotheses can be supported by data but cannot be proved absolute, as future studies may provide new findings. Scientists rely on peer-reviewed scientific reports to learn about new advances in the field, and scientific hypotheses must be tested and falsifiable. That is, it can be supported or rejected by evidence. Now, the second question we're going to ask is, what factors influence the strength of the conclusion of scientific studies and their relevance to humans? Well, every experiment should have a control group that is identical in every way to the experimental group, except for one factor, the independent variable. The independent variable is an experiment in an experiment is the one being deliberately changed in the experimental group. The dependent variable is the measured results of the experiments. The control group takes a placebo. It's a fake treatment that mimics the experience of the experimental group. The strength of the conclusions of a scientific study depends on the type of study carried out and the sample size. Now, our third question is, how can you evaluate the evidence presented in media reports or scientific studies? Well, media reports are not always completely accurate in how they portray the conclusion of scientific studies. To understand a study properly, it is often necessary to look at how the study was designed and to evaluate the strength of the study conclusions for yourself. Case control studies are observational studies in which cases who have a disease of interest are compared to controls who do not have the disease of interest to identify an exposure that is responsible for the disease in the cases. Researchers advise the public to exercise caution when reading media reports, encouraging the evaluation of technical data like p-values to identify trustworthy health information. And if your p-value is under 5%, that is probably a good study. Now, my fourth question is, how does the scientific process help us make important decisions about human health? In epidemiological studies, a relationship between an independent variable and a dependent variable does not necessarily mean one caused the other. In other words, correlation does not equal causation. Randomized clinical trials test participants are randomly chosen to receive either a standard treatment or a placebo or an experimental treatment. Now, double-blind trials or randomized trials is where the doctor doesn't know and the patient doesn't know. Well, this concludes my video presentation of the processes of science.